Hi, hello everyone. Today we are going to excited to present a project on enhancing authentication and authorization using machine learning based anomaly detection. Here, project is mainly focused on improving the cybersecurity systems to make them faster, smarter, and more reliable, especially in detecting the suspicious login and behavior using the machine learning models. By the way, in today's tech-driven world, securing user access isn't optional, where it's essential. Here in our project, there are three presenters where I am Anand Babu S. Then my two teammates are named as Sabarish J and Anbarasu. Here, the introduction is about why traditional systems fail, then why we need them. As cyber threats become more advanced, the traditional rule-based security systems struggle to keep up. The security operations centers or SOCs often face too many alerts, making it hard for analysts to reach catch real threats. We propose a user-centric machine learning framework to support those SOCs as Cybersecurity Operations Center. Think of it as a training a digital watchdog, where the more threats it sees, where it becomes to detect them and reducing the false positives and improving the cyber defense self operations. Then a problem statement. Here it mainly focuses on challenges in current cybersecurity systems. In SOCs today are overwhelmed by the thousands of alerts. Many of them are false alarms. This leads to alert fatigue and missed threats. Also, rule-based systems cannot adapt evolved cyber attack techniques. It's like trying to use an old GPS map in a new city. You will get lost. That's why we need adaptive intelligence systems that can learn and respond in real time. Then, this slide is denote that main part which we implemented in our project. What is SVM and how it helps in a project? We use the support vector mission as SVM, a machine learning algorithm that where it classifies the data by drawing a clear boundary between the safe and unsafe behavior. For example, if a user normally logs in Chennai at 9 a.m. and suddenly logs in Germany at 3 a.m., here the SVM detects its deviation. Why and how? Because SVM is fast and works well for the real-time detection of such anomalies. This diagram denotes about the SVM algorithm. Our main objective, what we aim to achieve means, it is used to build a smart adaptive security system that supports analysts by detecting threats early, reducing the false positive. Analysts focus on real threats and noise where we want to reduce the alert fatigue and improve response time. Then the next slide is about denotes the flow chart or block diagram. Here the points are about user login activity. In the user login activity, it defines about the source of login request, user IDs, IP address, location. We begin by collecting the raw authentication data like timestamps, user roles, IP address, etc. Then the second one is about data pre-processing. Here, it removes the duplicate and normalizes the data and convert it into a consistent format, where this step cleans and prepares the data where it ensures the machine learning model gets accurate input. Then ML model. Previously, I told that we use the SVM algorithm where it trained with the labeled data. The SVM model classifies whether the behavior is suspicious or normal. Anomaly detection output. Here, the model flag accesses the deviates from known safe behavior. If a user logs in a new location at unusual time, it will be flagged as an anomaly. Alert generation. Send an alert to the user security dashboard or admin. Only true suspicious activities generate alerts and reducing the false positives. Analyst feedback. Here it is optional, but it's valuable. Why? Because analysts can mark false positives and helping the model learn. Feedback helps the model improve continuously, like a security system that gets smarter with time. Then here next slide. is about methodology. Here, methodology is followed by three key phases: data collection and pre-processing. That we gather data as log, access pattern, and clean the data. Model training. It denotes that we train model using real attack scenarios and historical logging data. Real-time detection. The model monitors the live data streams and flags anything suspicious immediately. This makes it highly efficient for real-world use in the enterprise issues. Then, it is well that our framework has four modules. The first module is about cyber analysis, where this module predicts the threat using the user behavior, login trends, and activity patterns like digital detective. Then the second one is about dataset modification. That is defining the dataset by removing the unwanted data. It can be defined as clearly mean we can clean and refine the data by removing the outdated or irrelevant entries. Better data leads to better predictions. Then the next slide. It denotes the another two modules. Data reduction, where we reduce the data size and using the feature selection and compression, where it makes the system more faster and efficient. Risky user detection is the last phase of module of framework. Here, we track unusual user activity like late night logins, high data downloads, etc., and flag such behaviors for immediate review. Then the next slide is the requirements. Here we use tools like Visual Studio Code, Python, HeidiSQL. Visual Studio Code for development, HeidiSQL for managing and querying the database, and Python to implement the machine learning algorithms, especially the SPM model, which I previously said that. Using the libraries using the scikit-learn. Then this slide is the sample output where it shows the detected anomalies, risk levels, and possible user threats. These results can be displayed in the dashboard or integrated with the SIEM tools for real-time action. Then this slide is it represents the references. We build a project on a strong foundation where these references include well-known papers on intrusion detection and machine learning models like STM, decision trees, and deep learning. We compare different algorithms before choosing the one that best fit our real-time analogy detection. Thank you.